that slapping sound is that nicely going in and out. Actually, that slap thing.
Okay, now the printer's been moving. Originally the tray was way out here, and this tray at the bottom is the business end of this printer. You're supposed to plug that with something like plaster of Paris. And as this result column gets a new result, then when it tries to transmit this even column to an odd, there's a sector here to do that, but there's no odd column next to it. Instead, it causes all the horizontal bars over here to move back and forth, which causes these things to twist, which causes them to turn these things, and they actually take the number wheels and put them in the correct position, the result. And then, that set of things is printed on this paper with this set of number wheels, and there's also a set of number wheels down the bottom of the stamp, which gets stamped into plaster of Paris. Now, it's the plaster of Paris result that we're after. Okay? And this thing can be programmed to have 1, 2, or 3 columns. You can do things like 5 rows of numbers, skip a row, 5 rows of numbers, skip a row, stuff like that. And it's pretty precise. Now, as that tray is moving along, you don't know, the operator doesn't know that it's getting to the point where there's no more space to put any numbers. It's getting to what I would call the end. Well, Babbage took care of that. He has a lever in the back, and as the tray is moving along, now I hope you can go to the back, and I'll get down to the end here so everybody can see. As the tray is moving along, it hits this lever. The lever causes weight to fall, which pulls on a string. The string comes around here in the front, comes up over on this end. You can see it coming up right here, cross over to here, and it pulls on this clutch, which disengages the crank. And you can't crank it anymore. Well, you can turn the crank, but it won't do anything. So that means it's time to take the tray out, put it aside, let it dry, put new stuff in, and start all over. Continue on with the next set of calculations. By the way, you see this handle down here that Ray is cranking? Well, if you look carefully, you'll notice that the place to put the crank is right on the end of the main shaft. That was the design that Babbage had. But remember, he never built it. And because he never built it, he never got a chance to crank it. When the London Science Museum put it together, they put the crank on, and they tried to turn it. There were parts of the cycle where they were rating up to about 140 pounds worth of pressure. It's like trying to lift a 140-pound person. Okay? And you have to be steady, as Ray was saying. You cannot, because the load varies up and down. It's like a roller coaster. So they realized they couldn't do it. So they put a 4-to-1 reduction gear in. And that gets it down to about 30 or 40 pounds worth of pressure, maximum. And that most people can handle. Well, somebody one time in the crowd complained that this is no longer true to Babbage. We've changed it. And my response to that was very simple. Remember that 27,000 part design? He changed it to an 8,000 part design. And if he had built it, he would have said, I can't crank it, put a 4-to-1 reduction gear on this thing. In other words, we just completed the job. He had almost 99% completed. We only had about 1% to take care of. A half a dozen to a dozen minor things. But everything else is absolutely true to Babbage. Okay?
And I have to give the London Science Museum considerable credit. They consulted with historians on how the parts were made, the tolerances. They consulted with anybody and everybody. And when they came to something that needed to be changed or added, they really scratched their head for a long time saying, well, what would Babbage have done? Now, of course, they couldn't consult with Babbage, but they said, what did he do elsewhere on other designs? You know, would have solved a problem like this. So truly, everything that's been added that was necessary, Babbage would have done it probably the way that the London Science Museum.
You would be approving from working up in heaven together. By the way, this isn't the only thing he did in his life. Babbage had a real life. In 1814, he got married to Georgiana Whitmore. By 1827, which isn't a very long period of time, she was giving birth to their 8th child. She died in childbirth, and the child died with her. And later that year, he lost one of his sons and his father. So 1827 was a very tragic year for him. By the time he died in 1871, there were only 3 of his 8 children left. A lot of them had predeceased him. And one of his sons, surviving sons, is the one who got the stuff from this. He also invented the cow catcher on the front of trains. The mechanical switch to switch the tracks on the trains, train tracks. Pontoons to walk on water. I mean, he was involved in all kinds of things. He was a very interesting guy. He got a poem one time from Alfred Lord Tennyson, which had a line in it that goes something like this. Every moment dies a man, every moment a man is born to replace him. He wrote back to Tennyson and he said, "Sir, if this was true, our population would be stagnant. It would neither increase nor decrease. I propose on your next publication that you modify your sentence to say, every moment dies a man, every moment 1 1/16 are born to replace him." And by the way, 1/16 is only an approximation. So, this did not set well with Tennyson. So, you know, he was a very interesting character. You've got to admit that he was a very interesting character. Anything you want to add, Ray?
I think you've covered it pretty well. Maybe the print, well, people have seen the printer in action.
Yeah, and
I think somewhere we have a glass case, except it may have disappeared.
It's not here.
It's not here
It's right here.
anymore.
No, it is over here. It's over here.